The mystery of Betelgeuse, a giant at the edge of time. When we gaze up at the sun, we feel its warmth, its brilliance, and its life-giving power. It's the heart of our solar system, massive, blazing, and seemingly unmatched. Yet, in the grand scale of the cosmos, our sun is nothing more than a humble star. Among the real titans of the universe lies a celestial giant that dwarfs the sun in both size and drama, Betelgeuse. This red supergiant, glowing with a warm orange hue, resides in the famous Orion constellation, marking the left shoulder of the mythical hunter. Unlike many stars, Betelgeuse is visible to the naked eye. Especially during winter in the northern hemisphere, it stands out in the night sky, bright, bold, and mysterious. But Betelgeuse is not your typical star. It's unstable, unpredictable, and nearing the end of its life. Its brightness changes noticeably over time, a signal that something unusual is happening. This fading and brightening aren't just flickers, they're caused by internal turmoil. Betelgeuse expands and contracts in cycles, driven by powerful processes as it runs low on nuclear fuel. Some of these cycles are short, while others unfold over decades or centuries. In early 2021, Betelgeuse dimmed to a surprising low, triggering excitement and curiosity around the world. Could this be the final moment before it goes supernova? To understand why that question matters, consider this. Betelgeuse is around 640 light-years away. That means the light we see today actually left the star over 6 centuries ago. If it were to explode, we wouldn't witness it here on Earth until the light from that event finally reaches us. Possibly tomorrow, or maybe not for another 100,000 years. Even though Betelgeuse is cooler than our Sun, with a surface temperature around 3,500 Kelvin, it's far more massive, about 20 times heavier, and so gigantic that if it replaced the Sun, its surface would stretch past Jupiter's orbit. Despite its cooler temperature, its immense size allows it to release enormous amounts of energy. The name, Betelgeuse, is believed to have originated from Arabic, meaning, the armpit of Orion, a nod to its place in the constellation. Ancient stargazers knew of this giant, but only in recent years have we begun to unravel its mysteries with modern technology. Telescopes like Hubble and observatories like ALMA in Chile have given us extraordinary glimpses of Betelgeuse. These observations revealed giant plumes of gas, chaotic movements, and star spots, huge dark regions formed by intense magnetic fields. These spots are like solar flares on a colossal scale, sometimes many times larger than Earth, and can cover up to 20% of the star's surface. These features are not just surface decoration, they deeply affect Betelgeuse's brightness as seen from Earth. As these cooler patches rotate in and out of view, they alter the light we see, sometimes making the star appear to dim dramatically. One of the most astonishing findings is a massive plume of gas being ejected from Betelgeuse. These aren't soft whispers from the star's surface, they're violent shockwaves. Deep within, hot gas churns and rises, then cools and falls in wild, swirling currents. Thanks to high-resolution observations from telescopes like Hubble and radio observatories such as ALMA, scientists now believe that Betelgeuse's magnetic field is not just strong, it may be thousands of times more intense than the Sun's. These invisible but powerful magnetic lines weave through the star's surface and outer layers, shaping how gases rise, cool, and fall. They guide massive arcs of plasma, form towering loops, and carve out star spots, vast, dark regions that rotate in and out of view. These magnetic forces don't just sculpt the star's exterior, they also regulate the very light we see from Earth. When cool magnetic spots dominate its surface, Betelgeuse appears dimmer. When they fade or shift, the star brightens. It's a celestial dance of light and magnetism, visible across the gulf of space. But amid all this turbulence, one question looms large. Is Betelgeuse about to explode? The end of a star like Betelgeuse is not quiet. It doesn't flicker out, it ends in cataclysm. When the internal nuclear furnace can no longer hold off gravity, the core collapses in a fraction of a second. That collapse triggers a rebound, a supernova, one of the most violent and luminous events known in the universe. During a supernova, a single star can unleash more energy in a few weeks than our Sun will emit in its entire 10 billion-year lifespan. The explosion can shine brighter than an entire galaxy, briefly turning night into day for observers lucky enough to see it. And if Betelgeuse does explode in our lifetime, it could become one of the most spectacular sky events ever recorded by humanity. Astronomers predict that the supernova would be clearly visible in daylight for weeks, glowing brighter than the full moon in the night sky. It would become a cosmic beacon, impossible to miss, its light reaching Earth after a journey of more than 6 centuries through the vacuum of space. But despite the drama of such an explosion, there's no danger to life on Earth. Betelgeuse is distant enough, about 640 light-years away, that even its powerful blast would pose no threat to our planet. Instead of destruction, we would witness a rare celestial show, an event that hasn't occurred so close to Earth in recorded human history. Still, we're left with a mystery. When will it happen? That's the puzzle that keeps astronomers watching Betelgeuse night after night. The star has shown signs of instability, massive dimming events, gas ejections, surface cooling, all of which could hint at an approaching end. But none of these are guarantees. Betelgeuse could detonate tomorrow, or it might survive, pulsating and glowing, for another 100,000 years. And here's the twist, because its light takes centuries to reach us, it could have already exploded, and we're simply waiting for the brilliant aftermath to arrive. This uncertainty gives Betelgeuse a kind of poetic suspense. It's like a cosmic time bomb, ticking silently across centuries, its fate already written in physics, but not yet in our skies. And Betelgeuse is not alone in its grandeur or its mystery. Antares, another red supergiant in the constellation Scorpius, shares many of its characteristics, vast in size, glowing red with instability, and shifting in brightness like a heartbeat. Studying Antares and Betelgeuse side by side allows astronomers to decode the complex physics of dying stars, offering clues to the final stages of stellar evolution. These supergiants are more than just glowing dots in the sky. They are laboratories of extreme physics, where gravity and thermonuclear forces clash in cosmic proportions. By observing them, we gain not just data, but perspective. A reminder of how stars are born, live gloriously, and eventually die, seeding the universe with the elements that make life possible. So the next time you lift your eyes to the winter sky and see that warm red glow in Orion's shoulder, pause for a moment. You're not just seeing light, you're witnessing the final breath of a stellar colossus, a star that has watched over Earth through centuries of change, quietly undergoing